4.1, investigate nonlinear relations, investigation. So we're going to investigate what nonlinear relations, what one of them look like. And the one that we're going to do is, it's called a parabola, okay, a quadratic. So let's just recall an independent variable is the variable that you control, okay? And that's going to be in an experiment. And a dependent variable is the variable that you measure dependent on the independent variable. So as you control and as you change the independent variable, the dependent variable is going to be measured and that's going to change. Okay, so let's investigate. So the simplest equation for a linear relationship is y equals x. Okay, so let's actually sub in these coordinates from the x column into y equals x, and then we're going to actually plot this linear relation. So x is -3. Well, if x equals y and y equals x, then the x column is just going to be duplicated. Like x equals y, x equals y, x equals y, right? All the way down. So we can go ahead and graph that. And it's going to go up with the slope of 1. Here we go. And then that's going to be x equals y, or y equals x. Okay? I always kind of call it x equals y because when I'm referring to like the x column and then plugging in the y. So y equals x. That's the line y equals x. So now let's take a look at another one. Okay, so number 2, the simplest equation for a quadratic relationship, and that's what we're going to be studying in this unit, is y equals x squared. And then we're going to get into more complex ones and ones that we move around, flip, slide. Okay, so let's go ahead and calculate the y coordinate and plot the quadratic relation. So if we have y equals x squared, if we take -3 and we sub that in, we just do -3 squared and that equals 9. Okay, the next one is going to be y equals -2 squared, which is 4. And we're going to sub that in. Okay, -1 squared is 1, 0 squared, 1 squared, 2 squared, 3 squared. And if we look, and just want to point this out, what do we notice about these two numbers? What do we notice about these two numbers and these two numbers? Okay, as we get further and further away from 0, 0, the y coordinates are actually the same. So watch me plot it. 0, 0, 1, 1, and -1, 1. 2, 4, and -2, 4. 3, 9, and -3, 9. And that's what a quadratic is going to look like. So that's y equals x squared. So that's the base quadratic without any transformations on it. And that's what we're going to be learning for pretty much the rest of the year. Okay, so let's talk about a quadratic relation, and I really wanted to leave this this on the board right here. So the relation is defined by, y equals x squared is a quadratic relation. Okay, that's this right here. The graph of a quadratic relation is called a parabola. So parabola. So I always say that a parabola is a shape, and it's that happy face or the sad face shape. And we're going to get more into the sad face when we flip it. Okay, a parabola has a maximum or a minimum point, and I'm going to highlight that right here on the graph. This one right here, it's going to be the minimum point, right? And that's called a vertex. And we're going to get more into that, of course. If the parabola opens up, that means if it's a happy face, okay, the vertex is going to be a minimum because it's going to be at the bottom, right? So we'll go minimum. And if the parabola opens down, what's going to happen is the vertex is going to be maximum because it's going to be right at the top. Okay? Okay, a parabola is symmetrical. And a vertical line that passes through the vertex of the parabola is called the axis of symmetry. highlight that with green. So we're going to have a line right here. And what we're going to be able to do is we're going to flip that side of the parabola onto this side of the parabola, and it's symmetric. Okay, so this line that, like this vertical line that passes through the vertex, and of course right here is the vertex again, what this is called is the axis of symmetry, AOS. Okay, and so that is the line where we can reflect, and it's going to be symmetric. So those just are a few characteristics of quadratic relations. Okay, now what we're going to do is we're going to investigate finite difference of linear relations and then quadratic relations, and we're going to see the difference, okay? So for the equation y equals x plus 1, what we're going to do is we're going to fill in the table of values and then find the first differences. So everybody should be able to pause this and go ahead and fill in like the table of values just as a practice. Oops. Here we go, just as a practice. So we would be like doing -3 plus 1, -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1, and then 3 plus 1, right? Just subbing in those x values right here to this equation. Now, for first differences, just as a review, the x's has to go up by a constant. So the change in x here is 1. So the answer is yes, we can use first differences. So what we're going to do is we're going to subtract up. We're going to go 4 minus 3 equals 1. Okay, 3 minus 2 equals 1. 2 minus 1 equals 1. And all the way up, we're going to get 1s. Okay, so here we go. Are the first differences constant, and what does this mean? Okay, so the first differences are constant. So first differences are constant, meaning that this relation is linear. So this relation is linear. So think of it like this, because when we get up to the higher grades, it's going to be easier. Y equals x to the exponent 1. If the first differences are constant, the exponent on our x is going to be 1. Okay, now let's scroll down a little bit. Okay, now for the equation y equals 3x minus 2, let's fill in the table of values again. So we're going to do, and I'll just walk you through two of these. 3 times -3, which is -9 minus 2. 3 times -2, which is -6 minus 2. Okay, and we're going to continue to go. Three times -2, I'm just checking these. 3 times -1 is -5, and then -2, -5, -2. Okay, see how these are going up by 3s each time? And then 1, 4, and 7. 1, 4, and 7. So when we take the first differences, again, just as a review, we want to subtract up. So we would do 7 minus 4, and that would equal 3. And we're going to go 4 minus 1, and that's going to equal 3. And you guys keep going, but what we're going to see is we're going to have 3's all the way down this column. So are the first differences constant? Yes. Therefore, linear. Okay? Because it's first differences, we're dealing with x to the exponent 1. So our conclusion is the first differences of a linear relationship are constant. Let's investigate finite differences of a quadratic relation. So let's go ahead and fill in the table, and we're going to be using y equals x squared so many times that you're going to be able to memorize this. So -3 squared, -2 squared, -1 squared, 0 squared, okay? And then this part is going to be symmetric. So let's go ahead and calculate the first differences. 9 minus 4 is 5. 4 minus 1 is 3. 1 minus 0 is 1. 0 minus 1 is negative 1. 1 minus 4 is negative 3. 4 minus 9 is negative 5. So, are the first differences constant? No. What does this mean? Therefore, non-linear. Okay, pretty easy. Now, let's do the second differences. 5 minus 3 is 2. 3 minus 1 is 2. 1 minus negative 1, and don't forget about that double negative there. Okay, just be careful with that double negative. And that's going to be 2 and 2. Are the second differences constant? Yes. What does that mean? Therefore, it's quadratic. Okay, and just like I showed you in the other section, y equals x squared. If the second differences are constant, then the exponent on the x is going to be 2. Second differences, right, the number 2, and x squared, the number 2. Number 2, for this equation right here, what we're going to do is we're going to fill in the table of values and then find the first and second differences. Okay, so when we sub in the x values to this equation, what do we get? Okay, so I have on my calculator, I'm just going to fill this in. We get 8, and on the 0 was, so you can go ahead and pause, and then I'm going to fill these in. 0 was negative 1, this is 4, this is 13, this is 26. And then when I do negative 2, negative 1 is negative 2, and negative 2 is 1. Okay, now let's go first differences. 26 minus 13 is 13. 13 minus 4 is 9. 4 minus negative 1 is 5. Negative 1 minus negative 2. Sometimes I write these out because I get confused by the double negative. So negative 1 plus 2 is 1. Negative 2 minus 1 is negative 3. And 1 minus 8 is negative 7. Okay, let's go up this line. So we can see that the first differences are not constant. So are the first differences constant? No, therefore it's nonlinear. So we know already that it's not a line. Okay, so now let's go up the first difference column and let's fill in the second difference. 13 minus 9 is 4. 9 minus 5 is 4. 5 minus negative 1. 5 minus 1 is 4. It's an equal sign. 1 minus negative 3. 4 and negative 3 minus 7 is 4. So are the second differences constant? Yes. Therefore, it is quadratic. Quadratic. So what can we conclude? Okay, quite simply, the second differences of a quadratic relationship are constant. That's our conclusion. Okay, now let's talk about the axis of symmetry. So I already kind of stated this before, but let's zoom in on this. So let's make a table of values for this quadratic relation, okay? And then what we're going to do is we're going to graph it. So I'm going to sub in negative 4 squared plus 2 times negative 4 plus 1, okay? That's going to be 9. And then I'm going to just scroll over and change the 4 to a negative 3, and I get 4, then 1, then 0, okay? 4, 1, 0, then 1, then 4, then 9, okay? 1, 4, 9. So you should be able to already recognize that these are like the base parabola, okay? But now let's actually graph it. Okay, so negative 4 comma 9, negative 3 comma 4, negative 2 comma 1, and then we go here, here, and here. Okay, so this is what our parabola is going to look like. So it's going to be the exact same thing as our base parabola, except for it's just like moved over a little bit. Okay, so we can label that y equals x squared plus 2x plus 1. Okay, now what we're going to do here is we're going to draw the line where the graph is symmetric. So simply, I'm looking at it right now, and I'm like, okay, down this line, the graph is symmetric. And of course, I used a ruler there, okay? And this is called the axis of symmetry. So the number that the axis of symmetry has is -1. So it's actually the vertical line in the form x equals -1. And just a recap from grade 9, vertical lines are not in the form y equals mx plus b. They're in the form x equals x-intercept. Okay, x-intercept here is -1, so x equals -1 is this vertical line for the axis of symmetry. Of the note, it just says to note. So here's the difference between linear relations and quadratic relations. So linear relation is in the form y equals x, and the degree on this x is 1. Okay, and a quadratic relation is in the form y equals x squared, and the degree on that x is now 2.